All right, welcome back, everybody. I hope everyone had a good lunch. The next talk is going to be about Ubuntu app and scope development. I'm not going to go too deep into code here because we're not really set up to do a workshop. So I'm going to kind of hit on the high-level topics and talk about where you can get more information if you actually want to start developing. So first things first, we have an Ubuntu developer portal. It is developer.ubuntu.com. And it is going to be your very best friend if you are going to be developing anything at all for Ubuntu. It will cover app development, scope development, web app development. We've got this core section now, which covers Snappy Ubuntu Core, and that's going to be expanded to cover the new Snappy Personal that Rick talked about earlier, which is going to cover phones and tablets and desktops moving forward. So if you're a third-party developer that wants to target Ubuntu, everything that you need, everything you're going to want is going to be on this website right here. So bookmark that, come back to that frequently. We post a lot of blog articles on there. It's going to be somewhere you're going to be coming back to quite a bit. First thing that you're going to get there is instructions for getting started. That includes learning about the platform, getting the SDK, everything that you need to get set up on Ubuntu. Right now, we only support development on Ubuntu as a host. So if you're running Windows or Mac or even like Fedora, you're going to want to get a virtual machine set up for that. And we do provide virtual machine images also here on developer.ubuntu.com. So once you get set up, it's going to talk a little bit about the platform. The Ubuntu platform is a little bit unique because we've added some features in there to make development easier for you and also make things safer for the user when they start running your applications. So you're going to want to familiarize yourself with the differences between that and traditional Linux development. If you've done a desktop app in GTK before, things are going to be different in some really important ways. So you're going to need to learn about that. We have all kinds of tutorials on there that will walk you through your first app or your first scope. And these are designed to take you from having no knowledge at all of what you're doing all the way through to having a finished product at the end that you can actually upload to the store. They generally cover one specific use case just to get you familiar with the tools and the workflow and the process on that. In addition to tutorials, we also have a set of guides, which are more targeted to specific features or use cases that you might want to do. These aren't going to start you from the very beginning, setting up a new project, and they're not going to walk you all the way through to publishing it in the store. It's going to be specific to, I want to do this one thing, here's how you do it. We also have all of our API docs published on here. That's for QML, for HTML5, for C++ for scopes development, and Python for Autopilot. So all of those are on there. They're all searchable. That is the primary reference for any of our APIs. Even if you're using the Qt APIs that we get from upstream, we encourage you to use this because it will link to the Ubuntu-specific docs as well. And also because not everything from upstream is going to be available by default on Ubuntu. So use the API docs here, and you'll know that if they're on this web page, then they're on the phone, they're on the tablet, they're going to be on the desktop. All right, so getting started, the first thing you're going to do is you're going to get the Ubuntu SDK, and this is what it looks like. It is built on Qt Creator, so it's a very powerful IDE. It's got all kinds of great development tools built into it already. Syntax highlighting, project management, class overviews, everything you would expect in a modern IDE is going to be there. Once you get that installed and set up, the first thing you're going to want to do is you're going to want to tell it about your devices and create a kit. So to do that, you plug in your Ubuntu phone or your Ubuntu tablet into your USB. You need to make sure that it's got developer mode enabled and that it is unlocked, and then Qt Creator will automatically detect it. You can see here it's detected my my Nexus 4. It's got all the information it needs about it. And then here at the bottom, you're going to see something about kits. And kits are important when you're developing for Ubuntu because that defines your target device and OS setup. You can target something different from what you're running on your desktop, and you do that using a kit. So you can target an older version of Ubuntu on the phone if you're running like the latest Wiley on your desktop, or you can target Vivid on the phone if you're running Precise on your desktop. So you're going to want to set up your kit. You can tell it what version of Ubuntu you're going to target, and also what architecture you're going to use. So if you want to build something for a phone or a tablet, you're going to want to use an ARM-HF kit, and that's going to create a change root for you also, and it's going to do all your building locally on your host machine instead of on the actual device, but that's going to make sure that it's going to build properly for that device. If you don't have a phone or a tablet, you can use the Ubuntu emulator, and that's also easy to create. So right here under the list of devices is a big plus button. You click on that and it'll pop this up, and that's where you can define your emulator. All you have to do is give it a name, tell it what architecture you want to use, what release channel of Ubuntu you want to use. I've got develop proposed right here, which is currently Wiley, so that'll get you the latest and greatest. And you create that, and it takes a few minutes, and it'll pull in all of the packages and stuff out of the archives that you need to set up this emulator. It'll create the emulator, it'll create a change root for building packages specifically for it, and then it will list it on your devices here and make it available for use. It will also automatically create you a kit for the specific emulator setup that you defined. So as soon as you hit create and you wait for it to all finish, you're ready to start developing for that. So once that's all set up and you've got an environment that you can target, you need to choose your project. So when you go to File and New and you hit Create New Project, this is what you're going to get. Qt Creator provides a whole bunch of different classes and projects you can choose from. The ones under Ubuntu are the specific ones you're going to care about. We have different build environments. We started out with CMake. We now have support for QMake, so you'll see a lot of duplicates in here for CMake and QMake. For most people, it doesn't really matter to you. QMake is going to make cross-compiling a little bit easier, and that packages, I think, are working in QMake and not in CMake. But if you don't want to do something in C++, you just want to use QML, which I do because I like QML. It's really easy to use. You don't have to worry about compiling anything anyway. So you can use this QML project right up here at the top, and that makes things easier for you. If you're wanting to make a scope instead of an app, we've got a template for that. If you want to make an HTML app instead of QML, there's a template for that, and there's a template also for creating a web app. So if you've got a remote website and you want to create a app package for it that just kind of wraps the browser around it and adds some extra features, you can do that through here. The big question for developers is whether or not they should write an app or a scope. And there's a lot of confusion sometimes about what the difference is for these. Here I've got examples of a Reddit app and a Reddit scope, so you can kind of see them. Scopes are really good for delivering content. So if your primary goal is to get content to the user, make it searchable, and then have it open it up somewhere else like a browser, then scopes are really ideal for you. You don't need to write a whole app. You don't need to build a UI for it. You just want to say, okay, here's a JSON string of results, show it to the user and let them do something with it. That's what scopes are ideally used for. There is some interaction available with scopes. If you look at the app scope, you'll see that you can leave like ratings and reviews for apps. So there's a little bit of back and forth available, but not as much as a full-blown app. If you really care about the user experience and you want to make something specific to what you want to deliver, then an app is going to be the best choice for you, because then you do have full control over everything that gets displayed and how it's displayed and how the user interacts with it. But that also requires that you do all the extra work of actually building this. So it's a trade-off, and you have to decide which direction you want to go depending on what your actual goals are in doing this. So let's say that you want to build an app. You have two choices for building an app. You can go with QML, which is provided by Qt, or you can go with HTML5. We consider both of them first-class toolkits for Ubuntu. So we try not to say, native and HTML5 or native and web, because we consider HTML5 to be native just as well as Qt. But they do take different approaches, and they have different skill requirements. If you already are familiar with HTML5 and CSS and JavaScript and you're comfortable with that, then HTML5 is probably going to be a better choice for you. If you're familiar with C++ or you want just a really simple way of building an app, then QML is a really good choice for that as well. Both of them are going to have access to the same platform level features. So it's not so much a question of what features you want to do, it's just a question of what language are you most comfortable doing it in. There's some main components in an app that you'll notice. If you look at one of our Ubuntu phones that we've got at our table out there, you'll notice they all share the same primary features. They're all going to have this header area at the top that comes from the main view component that you use. That's going to give you page title. If you use tabs or a page stack for navigation, you're going to get an icon here at the left automatically for you on that. And then any actions that you add on there, it's going to come up with icons in the right. You can see here I've got the one envelope icon, and then I've got another 3-dot icon there. The toolkit is going to put that 3-dot icon on there for you. So you just say, here are all my actions. And if it can fit them all on the screen, it'll fit them all on the screen. And if it can't, it's going to set this drop-down menu for you there. And this is important because you have to think beyond just developing for a phone or just developing for an app. When you're writing an Ubuntu app, you need to think about convergence. And that means you need to think about how is this going to work on a larger screen or a different form factor screen. So by doing it this way, if you just say, okay, here's all of the actions that I want to make available to the user, then when it's on the desktop and they can all fit on screen, they'll all be on there like a toolbar. But when they're on a phone, it'll put it on as many as it can and put the rest in a drop-down menu. And then here below that, we've got these new sections, which let you change the content that are in the app based on the user selection there. And again, these are components that are available in both QML and in HTML5. So you shouldn't actually be able to tell the difference between a QML app and an HTML5 app. We've created a whole new UI toolkit for HTML5 specifically to make it look and work exactly the same as the UI toolkit that we made for QML. So all of those components are on there for both. We've introduced something called conditional layouts. This is something we added into QML. It's not really needed in HTML5 because responsive designs are pretty much a solved problem there. But for QML, they weren't. So we came up with this set of APIs that let you define different layouts for your app depending on different conditions. It's not just screen size, but that's a primary one. So if you get more screen size, you can change from being a page stack view to being multiple columns. We've got some other apps that actually nest layout conditional layouts inside each other. So one specific component will have its own set of conditional layouts that are independent of the rest of the app. And so I wish I should have put a screenshot of this. A guy named Nicholas made a program that really showed this off beautifully because he dragged the window open and everything was animated and it would slide into place and new layouts, and it was just really fantastic to watch. And conditional layouts are what let you do that. These are really an important thing for convergence because we don't want to stick the same layout on different form factors because what works well on a phone doesn't work well on a desktop. So you want it to be able to change and adapt to the actual form factor that you're running it on. And our goal of having phones that actually become desktops, it's not just that it has to do this at compile time or at startup time, but it actually has to be able to switch live when you dock or undock your phone. We also introduced something called grid units, which are our display independent size units. If you're an Android developer, you've probably experienced, I think they call it display independent pixels. It's a little bit different from that, but same general idea. So whether you're on a high definition screen or not, if you use grid units to set the size of your components, they're always going to be the same size, whether it's 1024 by 768 or whether it's a 4K screen. Your components are always going to be the same size. An important difference between grid units and what Android does is our grid units are actually independent of form factor also. So if you say a button is good at 10 grid units wide, that's the ideal size for a button. We want that to be an ideal size on the phone, on the desktop, or on the TV. So on the desktop, even if the screen pixel ratio is the same, a button's going to be a different size than it is on the phone just because it's a different user interface. You're not right here a few inches in front of you, you might be a couple feet away. And on a TV, when you're 20 feet away from the TV, you're going to want it to be a different size also. But as a developer, all you have to do is say, what in terms of grid unit. So a good button size defining grid units is going to be a good button size on the phone, on tablet, on desktop, or on TV, so that you don't have to worry about making those calculation changes in your app. We do that all in the toolkit for you. Now, I mentioned some of the differences that Ubuntu apps have to face. Some of them are really good opportunities. Some of them make things a little bit harder for you, but better for the user. And you need to think about them. One of the biggest of those is app confinement. All of the apps that run on Ubuntu phones and tablets, and soon on Snappy-based desktops, are going to be confined so that they don't have access to everything that the user has access to. Rick mentioned earlier, we had the desktop store that we tried to get a bunch of third-party developers to put their apps into and sell them. And we did have to strike this balance between making it easy for the developer to get their app in and making sure that their app was actually safe for users to install and run. And in order to protect our users with the desktop store, all of these apps had to be reviewed by an actual human, which meant they had to go look at the code and make sure that the code wasn't doing anything bad and recompile it and rebuild the package themselves. And that was just a huge time sink for us. We brought in groups of volunteers and trained them up on how to do this and let them loose on the review queue. And even they weren't able to keep up with this. In the 2012 timeframe, we did an app developer competition using Quickly and GTK. And we got about 300 apps. And I think only about 100 of those actually made it into the store, just because either they were stuck waiting on reviews or they got reviews and there was something wrong with their packaging, because deb packaging in a way that is acceptable by archive admins is a really hard thing to do. So only about a third of those apps in that contest actually ever made it into the store. And not long after that, the reviewers got bogged down and they got tired of doing the same thing over and over again. And so it all just kind of fell apart with reviews. So after that, we came back and we said, okay, we need a way for app developers to get apps in without it having to go through review. And we came up with a set of restrictions that had to be placed in order to let that happen. And that's what eventually became our app confinement story on the phone. And Ken's going to talk a little bit more about this in his talk later on, but I'm going to give kind of a high-level view. Just because apps are confined doesn't mean that they can't share data between them. But in order to share data, we needed to provide a third-party service that we trusted that would let them do that in a safe way so that they can't, steal user data without the user giving them permission to do that. The primary way we do that is through something called the Content Hub. The Content Hub lets one app say, I want a file of this type. And then it'll pop up this chooser here where they can say, okay, ask the user what app you want to get this content type from. And then the user has to say, okay, I'm going to give you access to this picture. And then the Content Hub takes care of the plumbing to give the requesting app access to that picture. The app itself is never going to have direct access to that. And it could go the other way too. So if you have a picture that you want to share with something, then you go to the Content Hub and say, okay, I want to share this picture with somebody. If you know which somebody, you can tell it exactly what. Or you can pop up this chooser here and say, okay, let the user pick, pick where they want to share it to. So you can share pictures, you can share music, you can share videos, files, you can share even links now, which is really nice. And text, does that work yet? Yes, so text snippets now too, you can share through the Content Hub. Another thing that you can do to escape the app confinement is with the URL dispatcher. And what this does is it lets your app claim a specific domain or URL pattern and say, okay, this is mine. I want to respond to requests for this URL. So I wrote a Reddit app. I told the URL dispatcher I want to respond to any URLs to Reddit. So now if somebody clicks on a Reddit link in the browser, it can pop up in my Reddit app, and my Reddit app can then show the actual content of that page in its own way. And if my app is already running, it will get a signal from the system that says, hey, somebody wants to open this URL, you need to handle it. So whether the app's running or not, I'll be able to get that. If the app isn't running and somebody does this, then it'll open the app, let me do my stuff, and when I'm done, it'll close the app for me automatically. So it cleans up after itself also. We provide something called online accounts. This is a central credential management system that we provide so that your app doesn't have to store usernames and passwords. It's all done on the system. It's all handled for you. You just have to request the token or whatever it is. There's different providers. There's OAuth providers, and there's a few others. So whatever they give you in terms of auth token, you can get out of that. And again, the user has to approve this for each app, and you can toggle it on and off which apps you want to have access to it. The nice thing about that is on the phone, I can enter in my Google account one time into the system, and Google Plus app can use it, the Gmail app can use it, the Gmail scope can use it, and I'm not having to enter in the same username and password multiple different places. And best of all, those don't have to actually store the username and password anymore either. In addition to app confinement, on the phone we've introduced Lifecycle Management. And this was something that we introduced to save the battery on the phone, and it prevents apps from continuing to execute in the background. When you flip away from an app on the phone, that process is going to get suspended. It's not going to run anymore. So it's not eating up your battery or your CPU. And if you start opening a bunch of apps and you're using up all your RAM and the system needs to free up some RAM, it'll go back through and it'll kill those frozen apps to free up some RAM. We have something called State Saver, which will let you save your app state at any point going along the way. And if the system kills your app to free up memory, when it restores it, when the user switches back to it, it'll use that State Saver information to restore your app to where it was before. But that introduces some problems. If you've got some long-running processes that you want to keep running, you weren't able to do that anymore. So we've introduced some additional services to help you with that. One of them is the Download Manager, which will let you set long-running downloads to happen in the background, and then your app will get notified when those are done. And your app doesn't even actually have to keep running during that. So the user can say, okay, start downloading this, and the user can close your app, and it'll keep downloading in the background. And when it's done, they'll get a notification pop up that says the download's complete, and if they hit, okay, I want to do something with that, it'll open it back up in the app that started it, and it'll pick up from where it left off. We've got a podcast app that uses that really well. It'll download all of your podcasts in the background, and you don't need to keep the app running. Several others use that too. We also introduced the Media Hub. This will let sound and video continue to run even when the app doesn't have focus. We didn't actually have to introduce any new APIs for this either, because Qt provides a set of APIs for playing audio, and we just tapped into those. So anything that you can play through the Qt audio APIs will go get passed off to the Media Hub, and it'll keep playing that even when your app process is suspended. So I can get my podcast client, I can set a few things to download, I can set something to start playing, and then if I flip to something else, the podcast app stops running, but the music keeps playing and the downloads keep going. So that's apps. Again, it's the same for both QML and HTML5. All of those APIs and stuff that I talked about is available for HTML5 just as much as it is for QML, with the exception of conditional layouts and grid units, because there was already existing solutions for HTML5 for those. So now moving on to building a scope. You have a couple choices to make again if you're developing a scope. We've got two primary kinds. We have sources and we have aggregators. If anyone's used the phone before, if you've seen the Today scope, that's an example of an aggregating scope. It doesn't provide data itself. It uses other source scopes to provide that data. So you need to decide which one you want to be. If you have a source that you want to add to an aggregator, you can do that with keywords. Keywords are something that we just introduced within like the last couple months or so, but it's a really neat addition, because now I can say I've got a source scope and I'm providing music, and all I have to do is add this music keyword in there and it'll show up in the music aggregating scope. If I'm providing some local restaurant data, I can tag it with the nearby keyword and it'll show up in the nearby scope. So the aggregator doesn't need to know about what source scopes are around anymore. It just needs to know about what keyword it needs to listen for. And the system is going to tie those together. You can go the other way if you wanted. If you wanted to build an aggregating scope that targeted only specific source scopes, you can do that also, and you can define which ones that you want to use. The second choice you have to make with scopes is whether it's going to use local data or remote data. One of the security features that we've built into this is the fact that your scope cannot do both at the same time. So if you have access to the user's files, you do not get access to the network to upload them to God knows where. So you have to choose, is it going to be local or is it going to be remote? If you're going to access the network, then you can't access the system, and vice versa. Just like with apps, you've got some primary components with scopes. Because scopes are search-centric, they're all going to have a query. The user is going to be able to provide search terms to your scope, so you're going to need to do something with those. And then your scope is going to return a bunch of different results, and it's going to be able to tell what categories are available and what categories a specific result goes into. You can't see it in this screenshot, but some of them also have a filter section at the top, and the scope's also responsible for saying what filters are available. They can also optionally use previews where they can show larger versions of the content and add one or more actions of what to do with that, because sometimes you've got one set of content and there's multiple things you want to do besides just open it. So we provide the ability to add different actions on there. Now, scopes, you don't actually build the UI yourself. The dash handles that for you, but we do provide a declarative UI format where you can define some customizations. So you can tell a specific logo to use, specific colors to use for the background of the header or behind the content. You get to define what card layouts that you use for the results. If you look at a phone, you'll see some are big squares, some are small squares in a list, some are small squares in a grid, some are a nice carousel that you can scroll through. All of that's done through a declarative UI. So you don't need to worry about layout and placement or how to pack widgets together. You just say, okay, this is the set of categories I have. This is how I want them displayed. Here's the results. And then the dash takes care of building it for you. So you as a developer, you don't need to be a UI expert. You don't need to think about user experience or user interface or anything like that. All you have to do is give it a little bit of customization to make it look like what you want it to be, and the dash takes care of that for you. Previews are another option that you have to give some additional information. Now you can also preview music and video in the scope itself. So they're tied into Content Hub now. If you've got like a music sample you want to show, or you want to play YouTube videos directly in the scope without opening up a browser or a separate app, you can do that now also through your scope. Location awareness is also available to all scopes if they want it. That's a flag that the developer has to put on there. And when they do that, the dash is going to add an option to disable that for the user. So the scope developer doesn't have a choice. If they want location awareness, the user is going to be able to disable it, and they're going to need to know what to do with that. But that's a really useful thing to have for a lot of them, especially things like the nearby scope, where you want to present only local restaurants, and you don't want to have to prompt the user to enter their actual location. The phone's got GPS for a reason. It should be able to do that for the user. Just like apps, you can use the online accounts, same interfaces and everything. So again, if you have your Google account in there and your scope needs to access something from the user's Google account, it can say, I'd like to use that account data. And the user, once they approve it, then it can go out and it can get their information. I've got a Gmail scope, which is really nice, that works that way. All right, so now you've built your app or you've built your scope. Everything's looking good. But you want to test it. You want to make sure that it's going to keep looking good. Unit tests, everybody should probably be familiar with. If you've written anything of any amount of complexity, you should be writing unit tests for it to make sure that works. You can do that with scopes and with apps using what the languages provide. So there's C++, there's QML, or HTML5. You can use whatever existing unit test frameworks there are for that. But we also introduced something called Autopilot. This was something that was developed several years back, initially to test Unity, and it's been expanded now to test scopes and apps as well. And Autopilot does integration testing. It doesn't test just individual pieces of code in isolation. It tests everything working together. So you write a script that says something like, go press this button, make sure this pop-up comes up. Go press this other button in the pop-up and make sure this other thing happens. So you build these big, complicated scripts that test multiple pieces of code interacting together to make sure that all works. Autopilot's written in Python. And again, it'll work for apps and scopes alike. It's a really important thing. Autopilot has been key to getting our quality up on the desktop, like Rick was talking about earlier. All right, so now you've got it written, you've got it tested, everything's looking good. You want to package it. This has always been where things got hard for Ubuntu, or any Linux distro really, when it was time to package it and get it published. Now with click packages, and soon with snappy packages, that's gotten a lot easier. So the first thing you're going to have is you're going to have a click manifest. That's manifest.json right there. And if you open that in Qt Creator, it's going to give you this nice interface to edit that in. You need to give it a name. They're all going to be namespaced with something. Mine's got this long com.ubuntu.developer thing in there that you're not going to use anymore. We switched to a shorter version of that, but apps that were already using the long version are stuck using the long version. So that's mine now. If you write something new, it's going to be your app name dot your developer name. So you give it the name, you give it your name and email address as the maintainer, give it a version number. The framework here is going to be the important one. So frameworks define what is available to your app, what the system is guaranteed to be there. I've got on here, I've got 14.10. It's not really actually tied to the release of Ubuntu. It's just kind of happened to coincide that way recently. And when you go to the API docs online, they're all broken up by framework also. So you know, if you're looking at the 14.10 API docs, that they're going to be available to the 14.10 framework. And this is going to let the app and the device know that they both have the same expectations about what's available. And the nice thing about this is it's going to provide you some backwards compatibility too. So if you write an app, you can target an older version of the framework and it's still going to run on newer versions of Ubuntu. So if you've got a device running 15.04 or even 15.10, it still has that 14.10 framework on there because we have maintained backwards compatibility for that. So any app that said that it worked with 14.10 is guaranteed to work on 15.04 and 15.10, which is, it sounds like a really obvious, easy thing, but traditionally that hasn't worked that way on Linux desktops. People, updated versions of the distro, we get updated versions of dependencies, things wouldn't work anymore. You have to rebuild and repackage your app for each new release that comes out, which if we're doing it every 6 months is quite often. So this way you don't have to do that anymore. It takes care of that. If for some reason we ever had to break compatibility with this framework, then devices would just not ship with that framework anymore and apps that need it would not be displayed in the store to be able to download. So that takes care of one of the biggest headaches with packaging and distributing apps on Linux. The next thing is going to be the AppArmor profile. AppArmor is what we use to provide app confinement, and this is going to define the things that my app is allowed to do. So it needs to access networking. It uses WebView because I embed websites inside it. It wants to be able to use the Content Hub, so I need to tell it that it's going to use the Content Exchange APIs for that. And again, this is all really easy. You just click the plus button there and add whatever you need there to be. If you are using Content Hub, you have to provide a Content Hub manifest file. This is all documented on developer.ubuntu.com, but you just have to make sure that file's there and it says, I am a source for this kind of content, or I am a destination for this kind of content. And that will help that picker when it prompts the user what app to use. That's how you get your app added in there. And if you're using the URL dispatcher, you need to give it a manifest file that tells it the domain name and the URL pattern that you want your app to be responsible for. All right, so once you have all of those files, it's time to build it. And instead of going to the command line and typing dbuild or sbuild or pbuilder or deb helper or whatever, there's like a dozen different commands to build deb packages on Ubuntu. Yeah. Instead of that, you go to the Publish tab in Qt Creator, and you've got buttons here. You click Build and Validate Click Package. And if it is a compiled app, if you've got C++ in there, it'll go to the change root, and it will compile your code. It will take everything, compiled or not, and it'll put it together into a click package with all of your manifest information. And then it'll run a series of validation checks on it. And these are the same checks that are being run on the store. So if something comes up saying, hey, your desktop file isn't right, or you didn't provide an icon or something like that, it's going to tell you right now what the problem is and how to fix it. So once all of those pass and you've got green check marks all the way down, Now you're ready to actually publish it in the store or install it on the device. Right here, you can click the Install on Device button. It'll copy that click package over to your phone or tablet and install it for you. So now you've got everything done and you're ready to publish it. So this is where the second worst part of getting apps out into Ubuntu came in before. You would stick your, actually you put a link to a PPA in the old desktop store. And then somebody would have to come along and get the source package from your PPA, look through every line of code to make sure you weren't doing anything malicious, re-upload that source package with their own signature to another PPA where it would build, and only after all that and everything passed would it get into the Ubuntu store. And that would take anywhere between a few days to a few months or longer. Sometimes, if something was wrong with the package and a developer didn't get back to it, it would just sit there waiting for an update for months or even years without ever getting in. So we've changed all that now. Now you take your click package that the SDK built and you upload it and you give it a little bit of information, not much. You'll notice you don't even have to give it the name or your name or anything else. You put it in there, you hit upload, and it's going to extract the manifest information out of your click package to get the name and the description and the icon. And then it's going to the package the same set of reviews that the SDK ran it through. Once it's all in there and it's happy with the package, you get the opportunity to add some metadata. So in addition to the title and description that it got from your manifest file, you're going to want to give it information about what category to put it in the store. You're going to want to upload screenshots or example videos so that users know what to expect out of the app. Someone's browsing through the store and they see an app without a screenshot, they're going to be less likely to download and try that. So it's important to go through and make sure that you get all of that right. Otherwise, your app's not going to get found. You can also translate all of that metadata. So instead of having it just in one language, which the old desktop store was, now you can translate all of that into whatever languages you want to support. And then if the user comes to the store and their phone is set to use that language, that's the version they're going to get. And that's not just the name and the descriptions, but you can even upload different sets of screenshots for different languages too, so that your screenshots are all localized as well. Now, the best part about the new store is that there are no humans doing reviews of it. Between simplifying the package and running apps under confinement, we can now run it through a series of scripts that will make sure that everything in that package is safe for the user to install and safe for the user to run. So the average time now, from my personal experience, between uploading a new version and getting that new version in the store is about 2.5 to 3 seconds. I will upload a new version and it'll say, okay, I'm processing it. And then I'll flip over to Twitter or Google Plus and I'll type new versions out. And by the time I hit enter on Google Plus or Twitter, it's already published in the store. You also get a set of download stats. So you can see not only how many people have been downloading over time, and it's separated between users and actual downloads. So if one user downloads it 3 or 4 times, it'll count towards the download stats, but not towards the user stats. So those are broken out. You get to see how many people downloaded each version of your app. So you can see, are people keeping up and updating? Are we losing users over time? And it'll give you a breakdown by country also. So you can see which countries your users are coming from, which you can use to then go add more translations for your app. The store also now has ratings and reviews. This is also something new that's landed in just the past few months. When users add ratings or reviews through the phone, you will now be able to see them in the store, and it's tagged with what version it is. So if somebody's got a bug going on and they leave a review saying, this is broken, it'll say what version of the app they had installed when they left that review. And that's it. You're done. You've got an app or a scope. It's in the store. Users can download it or buy it or whatever. You are now an Ubuntu app developer. Time to do it all over again. I've got half a dozen apps in the store. We've got people who have got 20, 30. I think Ogre has 50 apps in the store now. It becomes addictive. And because the languages that we chose for apps especially are so easy, you'll find yourself, you have an idea like, oh, I've got a free evening tonight. Let me build an app for that. And that's really all the time that it takes. So once you get your first app in, you're very likely going to want to keep going in and add more. All right, that's the end of my presentation. We got some questions already. Okay, so when we first, yeah, Ken knows the answer because he's got one. So when we first started back in, I think we kicked this off late in 2013, we had a new UI toolkit and a new SDK, and in theory, we had a new phone platform, but there wasn't actually any phone on the market. So we wanted a way to encourage developers to take that plunge and write apps for a phone that didn't exist. So we came up with this Ubuntu Pioneers program. If you go to developer.ubuntu.com/pioneers, you'll see everybody on there. The first 200 people to write an app and get it published in the store got one of these shirts. So you'll see a couple of us, Aaron, you have one. Rick's got one that he's not wearing today. Aaron's got one. So these were limited edition shirts. There are no more of those. It is too late to get yourself one. But you can go to that webpage and you can see all 200 people who did get one. All right, yes. Oh, let's get the microphone.
So you said that you've got an OAuth account management system. How do you handle all the browser redirect stuff? And I'm looking for technical details.
Very carefully. So we embed. We've got a browser component that I showed you, the auth port. It's based on Chromium. The component's called Oxide. It uses whatever the new rendering engine is, Blink. Yeah. Yeah. So you can embed this Chromium window into any app, and we've done that in the system settings. And so it handles all of the browser redirects and stuff for the auth providers.
Then how do you get the token out?
I don't know. Black magic, something Ken might know.
I haven't touched that code in a very long time, but I know who does know, and I can point you to him.
Yes. I don't know how it works, but it does. All right, in the back.
Are the OAuth providers limited, or anybody?
Any app can provide an auth provider. We don't have just the one OAuth. Every service has its own provider. So you've got a Google one, you've got a Facebook one, you've got a Twitter one. Okay. You have your own, you can ship that with your app and it'll get installed into the system settings where not only your app, but now other apps that the user allows can access those credentials. What do you mean going out? Okay, so okay.
That, as you might imagine, is not what the OEM is. If you have like a vertical.
Sorry, I think he's saying he has like a vertical application in the sense that like within some enterprise, they want a phone, but they want it to be locked down, probably with like 1 or 2 custom apps. Ubuntu, what, 20 custom apps? Yeah, so Ubuntu is really popular actually for that on tablets and phones because we do have tools where you can go in and nuke the parts that you don't like. We have the way it's laid out, the phone is laid out, is a little bit different than Snappy's laid out. We have something called the OEM partition where you can go in and customize, and some of the customizations are like, don't show this, don't show that. So it's, and then we have tools where you can author an image. So you could just roll your own if you wanted. Does that answer your question?
All right. Yep, one over here.
Yeah, when you were showing scopes, you had mentioned that there's a declarative UI so that you can show how the results are displayed.
Yeah.
Is that something that at runtime I could have a setting for the user that they could switch between those? Or is it something you hard code to the app?
It's just a JSON string, but I think it's only evaluated when the scope is first launched. So I don't think you can change that at runtime. You can provide different ones for different categories, but I don't think you can live switch back and forth between. All right, any other questions? Nope. All right, well, thank you, everybody. I do have a shirt to give away, and I'm going to give it to the gentleman in the back there who asked about corporate lockdown. So I have one 2X and the rest are XL. Which would you like? 2X?